Welcome to AI Frontiers, your trusted guide to the evolving landscape of artificial intelligence. In this episode, the focus will be on the frontiers of computer vision, with insights drawn from 16 cutting-edge research papers published on May 10, 2025. Computer vision stands as a pivotal discipline at the intersection of computer science, mathematics, and cognitive science, and it forms the backbone of many intelligent systems that permeate daily life. This episode will explore the latest advances shaping computer vision, distilling key themes such as interpretability, efficiency, robustness, and novel applications. Emphasis will be placed on technical innovations and emerging directions that are redefining the field. Throughout this journey, listeners will gain a deep understanding of the foundational research and the practical implications for the future of artificial intelligence. Presented by AI Frontiers, this episode aims to synthesize these advances into an accessible narrative, highlighting the most notable breakthroughs and what they signal for the future trajectory of computer vision. To appreciate the significance of recent breakthroughs, it is essential to begin with a foundational overview of computer vision. Computer vision refers to the science and technology of enabling machines to interpret and understand visual information, such as images and videos. The overarching goal is to empower computers with the capability to perceive, analyze, and respond to visual data in ways that parallel human vision. This interdisciplinary field draws upon artificial intelligence, machine learning, signal processing, and neuroscience, resulting in a rich tapestry of methods and perspectives. Applications of computer vision are widespread, ranging from everyday technologies like smartphone cameras and automotive safety systems to advanced domains such as medical imaging, industrial monitoring, and creative design. The challenges addressed by computer vision include the complexity of real-world scenes, variations in lighting and perspective, and the inherent ambiguity of visual data. As society generates ever greater quantities of visual information, computer vision serves as a linchpin for extracting meaningful insights, enabling more intelligent, responsive, and capable machines across diverse contexts. The first major research theme emerging from the May 2025 publications is interpretability and neuro-symbolic artificial intelligence. While deep learning models have achieved remarkable performance, their lack of transparency remains a significant barrier, especially in domains where model decisions have substantial real-world consequences, such as healthcare or autonomous vehicles. Transparent and interpretable AI is critical to building trust and ensuring accountability. One notable contribution is by Parth Padalkar and colleagues, who propose a framework for extracting symbolic rules from vision transformers. This neuro-symbolic integration blends the strengths of neural networks, such as pattern recognition and scalability, with the clarity of symbolic logic, paving the way for explainable and trustworthy AI systems. Through such innovations, artificial intelligence systems can become both powerful and understandable, addressing societal demands for transparency in decision-making processes. The second prominent research theme is the integration of multimodal learning and weak supervision in modern computer vision systems. Increasingly, vision technologies are required to process and combine multiple sources of information, such as images, textual descriptions, and even audio signals. The creation of fully labeled datasets for these tasks is often labor-intensive and expensive, making weak supervision, where models learn from noisy, incomplete, or unlabeled data, a vital strategy. For example, the work by Yicheng Song and collaborators demonstrates how unlabeled pathology image data can be effectively leveraged using multi-instance learning, thereby improving analytical performance in medical scenarios with limited annotation. These advances foster greater efficiency and adaptability, enabling computer vision systems to operate effectively in diverse, real-world contexts marked by data scarcity or noise. Efficiency, dataset condensation, and robustness represent a third set of interlinked research themes. As datasets and models grow in size and complexity, there is a pressing need for methods that reduce storage and computational demands without compromising accuracy. Ji Li and team advanced this goal by employing diffusion models for video dataset distillation, allowing the compression of large-scale data into smaller yet highly informative synthetic datasets. Concurrently, the FNBench project, led by Shufeng Jiang, evaluates federated learning systems under realistic label noise conditions, highlighting the importance of robustness to data imperfections and adversarial attacks. Unified learning architectures are also gaining prominence, supporting the development of computer vision models that are both efficient and generalizable, and thus better suited for real-world deployment. Turning attention to the technical building blocks supporting these breakthroughs, two concepts stand out: transformer architectures and diffusion models. Transformers are particularly adept at modeling global relationships within images and videos, enabling sophisticated contextual understanding through attention mechanisms that focus computational resources on the most relevant input regions. Diffusion models, on the other hand, have proven highly effective in generating diverse, high-quality synthetic data, which is essential for tasks such as dataset condensation and content generation. The papers discussed in this episode leverage these core technologies to drive progress in interpretability and efficiency, illustrating how foundational advances in model architecture can unlock new possibilities across a range of computer vision applications. Several key findings from the May 2025 research corpus are shaping the current state of the field. First, the method introduced by Padalkar and colleagues for extracting symbolic rules from vision transformers achieves a more than 5% improvement in classification accuracy, demonstrating that interpretability and high performance are not mutually exclusive. Second, Zhe Li's video dataset condensation approach, leveraging diffusion models, delivers up to a 10% performance gain in downstream tasks, illustrating the potential for significant efficiency improvements. Third, Jiang Lu's work exposes critical safety gaps in generative models through novel attack methodologies. Fourth, the FN Bench benchmark by John and collaborators reveals vulnerabilities in federated learning systems when exposed to label noise. Finally, Chunming He's Unfold IR framework narrows the gap in unsupervised image restoration, particularly under challenging illumination conditions. Collectively, these findings define the cutting edge of computer vision research, emphasizing interpretability, efficiency, safety, and robustness. The methodologies driving these advances in computer vision are diverse yet interconnected. Transformer architectures, equipped with attention mechanisms, are widely used for capturing global context in both images and videos. Diffusion models have been embraced for synthetic data generation and dataset condensation, enabling the creation of representative, high-quality samples. Neural architecture search is being employed to optimize model structures for specific domains, automating the discovery of architectures that are both efficient and high-performing. Multitask and multimodal learning frameworks are facilitating improved generalization by integrating multiple tasks or data modalities within a single model. Additionally, techniques in regularization and loss function design play a vital role in counteracting the effects of data noise and class imbalance, further strengthening model robustness and reliability. One influential paper highlighted in this synthesis is that of Padalkar and colleagues, focusing on symbolic rule extraction from vision transformers. This work merges the interpretability of symbolic reasoning systems with the representational power of neural networks. By introducing a sparse concept layer, the authors enable the formation of interpretable representations within the transformer architecture. The FoldCM algorithm is utilized to produce concise, executable symbolic rules that directly inform model decisions. Notably, this approach outperforms standard vision transformers in classification accuracy, exemplifying the advancement of explainable artificial intelligence in vision. The integration of symbolic reasoning with deep learning in this work sets a new standard for transparency and trustworthiness in complex model systems. The paper by Zhe Li and collaborators, spotlighted for its impact on video learning, addresses the challenges of scale and efficiency through innovative dataset condensation techniques. The introduction of VSTUnet and TAC-DT allows for the selection of diverse and informative video samples, ensuring that the condensed synthetic datasets retain the essential spatio-temporal features of the originals. This enables high model performance with significantly reduced data and computational requirements. The methodology democratizes access to deep learning by lowering resource barriers and facilitating efficient experimentation. As a result, this work is recognized for its contribution to making advanced computer vision models more accessible and scalable. Another key contribution comes from Shufeng Jiang and colleagues who present FN Bench, a benchmark designed to evaluate federated learning systems under realistic label noise. FN Bench simulates three types of noise: synthetic, human error, and systematic mislabeling. 18 contemporary methods are evaluated across vision and text datasets, providing a comprehensive assessment of model robustness. The authors additionally propose a new regularization technique to enhance resilience to noisy labels. This work is significant for its role in promoting safety and reliability in artificial intelligence, offering a unified framework for the rigorous evaluation of federated learning models as they transition from research to real-world deployment. Looking forward, the field of computer vision presents both significant opportunities and pressing challenges. Neuro-symbolic artificial intelligence is expected to play a central role in enabling transparent and safe decision-making. Automated and efficient models, optimized for deployment in real-world environments, will become increasingly important as applications diversify. Unified frameworks capable of multimodal and multitask learning are anticipated to improve adaptability and generalization in complex settings. Addressing practical issues such as data noise, distribution shifts, and operational constraints will require innovative methodologies and robust evaluation protocols. The continued development of open benchmarks and tools will drive reproducibility and accelerate progress, ensuring that advances in computer vision remain accessible and verifiable. A technical trend gaining prominence is the unification of learning through multitask and multimodal approaches. Multitask learning involves training a single model to perform multiple related tasks, while multimodal learning refers to the integration of diverse input types such as visual, textual, or audio data. This paradigm enhances model efficiency and adaptability, particularly in environments characterized by high complexity and variability. By balancing generalization with task-specific specialization, unified learning strategies are driving the emergence of new applications and research directions in computer vision and artificial intelligence at large. The synthesis and review of this episode have been produced using advanced artificial intelligence tools. OpenAI GPT 4.1 was employed for comprehensive analysis and narrative generation, while DeepGram technology facilitated text-to-speech audio synthesis. Visuals were created using OpenAI image generation tools. Human experts reviewed all content to ensure accuracy and clarity, although some minor oversights may persist. Complete references to all discussed research papers are provided, supporting transparency and further exploration. This multifaceted approach ensures that listeners receive accessible, up-to-date insights into the most recent developments in artificial intelligence research. You have reached the conclusion of this exploration into the frontiers of computer vision research, guided by the latest advancements published in May 2025. Listeners are encouraged to subscribe for more in-depth analyses and daily updates on breakthroughs in artificial intelligence research. The AI Frontiers channel is dedicated to guiding audiences through the rapidly evolving landscape of AI, helping all to stay curious and informed. References to all discussed papers are available for those who wish to delve deeper into the original research. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights.